Hello everyone and welcome to the complete interview guide for the front-end developers. In this video, I am walking you through the most common front-end interview questions from React.js to Next.js and everything in between. Simple explanations and real code examples. So let's dive in. So let's start with the browser fundamentals. We are going to start with DOM, that is Document Object Model. So first of all, what is DOM? When you visit a web page like this one, the server sends a raw HTML file to your browser. You can view this raw HTML file by selecting the view page source in your browser. And this shows the original HTML document exactly as it was sent by the server. However, the browser does not display the raw HTML directly. Instead, it parses the raw HTML and converts it into a structured representation called the DOM or Document Object Model. The DOM is a tree-like structure where every HTML element becomes a node or an object. This structure allows the browser and JavaScript to interact with the page. You can see the actual DOM tree using the browser's inspect or developer tools. In the elements panel, the DOM tree is displayed and you can inspect elements, edit HTML, modify styles and see how the UI is structured. So suppose you want to edit a section or suppose you want to edit this title, you need to just click this icon and select this section. Then you can edit this h1 tag, that is title. So let's say just we want to put edit, then enter, and you see the title is changed. So in this way you can check or inspect how UI in the browser is working. So in summary, the view page source shows raw HTML sent by the server and inspect element shows the DOM tree created by the browser. The next question can be, how does event bubbling and event capturing work in React? In React, there are two phases of event propagation, that is event capturing and event bubbling. On-click capture runs during the capturing phase and on-click runs during the bubbling phase. So during the capturing phase, the event travels from the top of the component tree down to the target element. After reaching the target element, the event moves into the bubbling phase where it travels from the target back up to its parent components. So now let's look at this example. Here both the parent div and the child button have event handlers and the click me button is the target element. When you click the click me button, the order of execution will be parent capturing, then child capturing, then the bubbling phase, that is child bubbling, then the parent bubbling. So this is the console output. Now if you don't want the event to reach the parent component, you can stop it using the event.stop propagation. So this prevents the bubbling phase from continuing upward, so the parent's on-click handler will not run. So the console output will be parent capturing, then child only. The parent's bubbling handler never runs, that's why parent bubbling will never print. Now let's look at a common real-world example of event bubbling. Imagine we have a modal or pop-up. So when you click outside the modal, it should close, but when you click inside the modal content, it should stay open. First, let's look at this code snippet. Here we have an overlay, which is the background layer that covers the whole screen behind the modal. The overlay closes the modal when it is clicked. However, there is a problem. When you click inside the modal, the click event bubbles up to the overlay because of event bubbling. As a result, the overlay's click handler runs and the modal closes unintentionally. So how do we fix this? The solution is very simple, that is we need to use event.stop propagation in the modal content div. By stopping the event propagation, the click event does not bubble up to the parent overlay. Because of this, clicking inside the modal content will not close the modal, but clicking outside the modal will still trigger the overlay on click handler and the modal will close. And that's a practical example of controlling event bubbling in React. Now let's move to the core concepts of React. React works with something called the virtual DOM, which exists alongside the real DOM. Updating the real DOM directly is expensive and can slow down the application. So instead of updating the real DOM on every change, React uses a virtual DOM. The virtual DOM is a lightweight copy or representation of the UI. When a state changes, React does not immediately update the real DOM. Instead, it first creates a new virtual DOM tree. Then React compares this new virtual DOM with the previous one. This process is called diffing. After finding the differences, React updates only the parts of the real DOM that actually changed, instead of re-rendering the entire UI. So this process is called reconciliation. Because of this approach, React minimizes expensive DOM updates, which makes application faster and more efficient. The next important concept that is often asked in interviews is props versus state. We use both props and state frequently in React development, but they serve different purposes. Props are basically read-only data passed from a parent component to a child component. Props are immutable inside the child, meaning the child component cannot modify the props it receives. The child can only use them to render UI or pass them further down. On the other hand, state is mutable. State is data that belongs to a component and can change over time. When the state changes, React re-renders the component to update the UI. So the main difference is props passed from parent to child and cannot be changed by the child, and state is managed inside the component and can be updated. So a simple rule to remember is, if the UI should update, use state. If its configuration passed from a parent, use props. Now we'll talk about React hooks, which is one of the most favorite topics in interviews. The first hook is useState, which we have already discussed. useState allows a component to store and manage state. When you call useState, it returns two things: the state value and a setter function. When you call the setter function, React schedules a re-render of the component and updates the virtual DOM, which eventually updates the real DOM. The next important hook is useEffect. It basically runs after a component renders. There are basically three ways to use useEffect. The first one is when we don't provide any dependency array, so it runs on every render. This one runs on every render. And the second case is when we provide an empty dependency array. Here the effect runs only once when the component mounts, meaning when it is first inserted into the DOM. And the third case is when we provide a specific dependencies. So here the effect runs whenever the count value changes. Now here is a tricky interview question. Suppose inside useEffect we update the same state that we also put in the dependency array. For example, if count is the dependency array and inside the effect we call setCount, this can create a problem. What happens is that when count changes, the useEffect runs. Inside the effect we call setCount, which updates the state. Since the state changed, React re-renders the component. After the re-render, count has a new value again, so useEffect runs again. This process keeps repeating, and as a result it creates an infinite render loop. So when using useEffect, we have to be careful not to update a state inside the effect if that same state is also listed in the dependency array, unless there is a proper condition to stop the loop. During interview, you might be asked to write code to fetch data from an API. A simple and clean way to do this is by using async await with a try catch block. First we use a try block to fetch the data. Inside the try block we call the API using await fetch. After that we check whether the response is successful. If the response is not okay, we throw a new error. If everything is fine, we convert the response to JSON and then return the data. If something goes wrong, the execution moves to the catch block, where we handle the error and print the error message to the console. The next hook is useReference. The useReference hook is used when you want to store a value without triggering a re-render of the component. Sometimes you need to keep a value in memory, but changing that value should not update the UI. In those cases, we use reference instead of useState. So the main difference between useReference and useState is, in useState, when the value changes, the component re-renders and the UI updates, and in useReference, when the value changes, the component does not re-render. This makes useReference useful for things like storing mutable values, keeping track of previous values, accessing DOM elements, etc. So a simple rule to remember is, if the value should update the UI, use useState, and if you just want to store a value in memory without re-rendering, then use useReference. The next hook we are going to discuss is useMemo. useMemo is used to memoize values. It runs during the render phase and helps avoid expensive recalculations. We usually use useMemo when a calculation is computationally expensive, and we only want to recompute it when its dependencies change. For example, here the calculation will only run when the count changes. Otherwise, React will reuse the previously memoized value. Now, you might think you can do the same thing with useEffect and extra state. This will work, but there is a problem. When count changes, React renders the component once because count changed. After the render, useEffect runs and calls setDouble. Updating state triggers another render, so the component renders twice. However, with useMemo, the calculation happens during the render itself, so React only needs one render to compute and display the updated value. Because of this, useMemo helps avoid unnecessary renders and expensive calculations, making it useful for performance optimization. The next hook is useCallback, which is used to memoize functions. Normally in React, when a component re-renders, new function instances are created. This means the function reference changes, even if the function logic stays the same. Creating a new reference can be problematic because React compares profs by reference. If the reference changes, React thinks the prof has changed. useCallback helps by keeping the same function reference between renders, as long as its dependencies do not change. Here reference means the memory address of the function. For example, here in this example, React will reuse the same function reference on every render because the dependency array is empty. However, an important thing to remember is that useCallback alone does not prevent re-renders. It becomes useful when used together with React Memo. React will skip re-rendering the child if its profs have not changed. But if the parent passes a new function reference on every render, React will think the prof changed and will re-render the child. By using useCallback, the function reference stays the same, so React Memo can correctly skip the child re-render when dependencies are unchanged. So in short, useMemo memoizes values and useCallback memoizes functions. The next concept is useContext, which is used to avoid prop drilling. Sometimes in React we need to pass data from a parent component at the top of the component tree to deeply nested child components. Normally we pass this data through props. However, when the component tree becomes large, passing props through many intermediate components becomes tedious and hard to maintain. This problem is called prop drilling. To solve this, React provides the Context API, which allows us to share data across components without passing props manually at every level. First, we create a context using createContext. Then we wrap part of the component tree with a context provider which supplies the shared data. Components inside that provider can access the value using the useContext hook. For example, we might create a theme context using createContext. Then we wrap components with the provider. So now the navbar component can access the theme using useContext. We can also wrap multiple components inside the provider. For example, in this case, the navbar, sidebar, and main can all access the theme value. Another important concept is nested providers. You can have multiple providers of the same context, and in that case the nearest provider wins. So for example, here navbar
gets dark and sidebar gets light.
In a front-end interview, you will often be asked about performance optimization in React. There are several techniques to improve performance. First, we already discussed about useMemo and useCallback. These hooks help avoid unnecessary calculations and unnecessary re-renders. useMemo memoizes computed values and useCallback memoizes functions. Using them properly can help optimize rendering performance. Another important technique is lazy loading. Lazy loading means loading components or resources only when they are needed, instead of loading everything at once when the page first loads. For example, in a scrollable page, components, images, or content can be loaded only when they appear in the viewport. This reduces the initial bundle size and improves loading performance. Then we use suspense to show a fallback UI while the component is loading. Here, suspense displays a fallback UI while the lazy component is being loaded. So this approach improves performance by reducing initial bundle size, loading components only when needed, providing a fallback UI during loading. Now let's move to the Next.js. In interviews, you might be asked, why would you use Next.js instead of React? React is a library for building UI, while Next.js is a framework built on top of React that provides additional features. One major difference is routing. In a typical React application, we use React router, where we need to define routes manually, like home, then about. We need to define it manually. But in Next.js, routing is file-based. This means that when you create a file inside the app or pages directory, Next.js automatically creates the route for that file, so we don't need to configure routes manually. Another important feature is server components and client components. In Next.js, components are server components by default. But if we need client-side interactivity like useEffect or useState, we must add the directive that is useClient. This tells Next.js that the component should run on the client side. Next.js also provides built-in API routes. Inside the API folder, we can define backend API endpoints. These functions run on the server, allowing us to create simple backend logic inside the same project. Another very useful feature is handling calls using a proxy. Sometimes the backend API endpoint is fixed and we cannot modify its CORS configuration. In a normal React app, this can cause CORS error when making requests from the browser. With Next.js, we can solve this using a proxy through API routes. Instead of calling the external API directly from the browser, we call a Next.js API route, which then forwards the request to the external backend. Since this becomes server-to-server communication, the browser no longer blocks it with CORS restrictions. Another important topic you might be asked about in interviews is authentication. There are basically two common types of authentication mechanisms, that is session-based authentication and token-based authentication. In session-based authentication, when a user logs in, the server creates a session. A session ID is generated. This session ID is sent to the client, usually stored in a cookie, and the server stores the user information associated with that session ID. On every request, the browser sends the session ID cookie, the server looks up the session data and authenticates the user. So the important thing to remember is that in this approach, the server stores the session data. But in JWT authentication, when the user logs in, the server generates a JWT token. That token is signed with a secret or private key. That token is sent to the client. The client stores it often in local storage or cookies. On every request, the client sends the token. The server verifies the signature of the token. If the token is valid, thus the user is authenticated. So in this approach, the server usually does not store session data because the token itself contains the user information. So there's the main difference. So in summary, in session-based authentication, the server stores session data, and in JWT authentication, token itself contains user information and server verifies the signature. So JWT is more scalable because it is stateless. The very next important interview question after JWT versus session is usually, where should you store the JWT? Local storage or cookies? So the answer is JWT should preferably be stored in HTTP only cookies, not in local storage, because local storage is vulnerable to XSS attacks. The next topic is offset versus cursor pagination. Pagination is used to efficiently retrieve data from a database. Instead of loading all records at once, we only fetch a small portion of data at a time, which improves performance and reduces load on the database. There are basically two common types of pagination. That is offset pagination and cursor pagination. In offset pagination, we use limit and offset. Here, limit is 20, meaning it will return 20 records, and offset is 40, meaning it will skip the first 40 records. So it is very simple to implement. The next one is cursor pagination. In cursor pagination, we use a unique identifier such as an ID or timestamp instead of offset. Here the cursor or the unique identifier tells the database where to continue. The next page starts after the last fetched record. Big platforms like Instagram or Twitter use cursor pagination instead of offset, because with offset pagination, the database must scan and skip many rows before returning the results, which becomes slow when the dataset is very large. With cursor pagination, the query starts directly from the last seen record using an ID or timestamp, so the database does not need to scan skipped rows. So we can say that cursor pagination is faster at scale, more consistent, and better for real-time feeds like social media. Another favorite interview topic is state management. We already know that we can create global or shared state using useContext. However, there is a limitation. When we use context, every component that subscribes to that context will re-render whenever the context value changes, even if the component only needs a small part of the state. For example, here navbar, sidebar and main all consume the same context. Now suppose the context value changes. Even if only navbar actually uses the changed data, all three components will re-render because they are subscribed to the same context. This can cause unnecessary re-renders, especially in large applications. To solve this problem, we can use state management libraries like Redux or Zustand. These libraries allow components to subscribe only to the specific piece of state they need. For example, suppose we have two pieces of state, that is theme and count. With Zustand, we can create a store where theme display subscribes only to theme and counter display subscribes only to count. In the theme display function, there is a button called toggle theme, and in the counter display function, there is a button with plus icon. Now when we click plus, only counter display re-renders. Theme display does not re-render. And when we click toggle theme, only theme display re-renders. Counter display does not re-render. This happens because Zustand allows fine-grained subscriptions, meaning components can subscribe only to the specific state they need. In contrast, context updates all consumers whenever the context value changes. Redux is actually more advanced than Zustand and provides a larger ecosystem. For example, RTK query helps with automated data fetching and caching. Without RTK query, we usually have to manage many things manually, such as fetching data, loading states, error handling, caching, and refetching data. But RTK query automates most of this process. It automatically handles data fetching, caching, background refetching, and loading or error states, which reduces boilerplate code and simplifies API state management. So in short, Zustand is for lightweight and simple state management, and Redux plus RTK query is more powerful ecosystem with built-in tools for complex applications and API management. In interviews, you might also be asked some basic JavaScript questions. One common question is how to remove duplicate from an array. A simple way to do this is by using a set, because a set only stores unique values. So we can convert the array into a set and then convert it back into an array using the spread operator. Another common question is double equal versus triple equal. Double equal is called loose equality because JavaScript performs automatic type conversion before comparing values. On the other hand, triple equal is strict equality, which checks both the value and the type. For example, the string 5 and the number 5 are equal with double equal, but they are not equal in triple equal. because their types are different. You may also be asked about null versus undefined. Undefined means a variable has been declared but not assigned any value yet. On the other hand, null represents an intentionally empty value. For example, if we declare let a, it will be undefined. But if we declare const b equal null, we are intentionally setting the value to empty. Another frequently asked concept is debounce. Debounce means delaying the execution of a function until the user stops triggering an event for a certain amount of time. This is commonly used in search inputs. For example, when a user is typing in a search bar, we should not send an API request on every keystroke. Instead, debounce waits for a short delay, such as 300 milliseconds, after the user stops typing and then sends the request. Finally, you may be asked about deep cloning an object. One modern way is using a structured clone. Which creates a proper deep copy of objects including dates, maps and arrays. Another older method is JSON parse, but this has limitations. It can lose certain data types such as date, map, set functions and undefined values, because JSON only supports basic data types. So in summary, these are some of the basic JavaScript concepts that are frequently asked in front-end interviews. Then you might also be asked some basic CSS questions, especially if you are using Tailwind CSS, which is a modern utility-first CSS framework. For example, one common question is how to center a div horizontally and vertically. In Tailwind, we usually use flexbox utilities. By setting the container to flex, we can use item center to align elements vertically and justify center to align them horizontally. Another common topic is CSS positioning. There are several types of positioning. Static is the default positioning. Here the element stays in the normal document flow. In relative positioning, the element remains in the normal flow but can be shifted relative to its original position. And in absolute positioning, the element is removed from the normal flow and positioned relative to the nearest positioned ancestor or the viewport if none exists. Then in fixed positioning, the element is removed from the flow and positioned relative to the viewport, so it stays in the same place even when the page scrolls. Then in sticky positioning, the element behaves like a normal element in the flow until a scroll threshold is reached, after which it becomes fixed within its container. If you want to learn more about Tailwind CSS Essentials, you can check this blog. In that blog, I explain the key concepts and utilities needed to work efficiently with Tailwind. So these are some of the common front-end topics that often come up in interviews, including React concepts, performance optimization, state management, JavaScript fundamentals, and CSS basics. Thank you.